value types store their data directly, because they're just values, in the same way primitives are in other languages. When you assign a value type object to a variable, it stores the actual data, with nothing in between. In contrast, a variable with a reference type object stores a pointer or reference to someplace in memory. The difference in how data is stored directly affects the behavior you get. With value types, each object is separate and independent, even from its own clones. You can make a copy of your variable, and this copy will be completely isolated from the first one. You can change it any way you want, while the first object will be left intact. Copying reference type objects works quite differently. Instead of getting a separate object, you get a separate reference to the same object. In this illustration, you copy the number which stands for the memory address, but the actual data in memory doesn't get duplicated. Basically, creating another reference will only affect the object's reference count. At this point, you can access the object from multiple places, and if you make a change using one of the references, the other will reflect the same change. This concept of shared state comes handy quite often, but it also introduces the risk of unintended changes, because you don't always control each reference. It's as if you enabled anyone with the link to edit your Google Doc, and one of the editors accidentally posted it on Twitter.